Hello guys, today I'm just making a video on solving questions related to the topic energy transfers. Now this is for the iGCSE and GCSE physics, so this video will help you guys to gain an understanding on how to solve questions related to this topic. And if you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's begin with the video. Alright, so the first question states that an electrical circuit is shown in the figure below. Okay, so we can see some battery here. So what we have to understand is that this is considered a battery. Okay, and the current in the circuit is direct current, so that means it only flows in one direction. Now, what is meant by direct current? Now, what we have to understand about direct current is also known as DC. So direct current just stands for DC. So if you see DC anywhere, it stands for direct current. Now, direct current is something, it's just basically current that is always in the same direction, that flows in the same direction. So we're going to take this point here. It's current that is always in the same direction. It just flows in the same direction. It's never going to change. Alright, let's move on. So that's for 1 mark. Let's move on to the next question. Next question states that the equation, alright, let's just zoom in a little bit here so that we can see the questions more clearly. So you have to understand is that the equation which links current, potential difference, and the resistance is potential difference is equal to the current times the resistance. Now we have to calculate the potential difference across the battery in the circuit in the figure above. Now, what key point is that they've given us the formula already for solving this. Now all we need is to know the current and the resistance. So for potential difference, what I like to give it as a symbol V. That's what potential difference stands for. And the current in this case is going to be 0.4 amps. That's going to be 0.4 amps since it's given from the question itself, and you're going to multiply the resistance in this case. So what you can notice about this is that this is a series circuit. So in a series circuit, the resistance technically adds up. So what I mean by this is we're going to say that the resistance and resistance usually are. So resistance is going to be 20 ohms plus 10 ohms. This symbol just means ohms. So that's something that I have to understand about physics. So 20 ohms plus 10 ohms, that's going to give you about 30 ohms. So you're going to write that down. The voltage is equal to 0.4 amps times 30 ohms. It's equivalent to 0.4 times 30 amps. It's equal to 12, actually 30 ohms. It's going to be 12 volts. So that's going to be your answer. It's going to be 12 volts. That's going to be for 3 marks. You just got to show the working, and you're going to say that you have to show that the total resistance is about 30 ohms, and you have to calculate the voltage. So the voltage in this case is going to be 12 volts. Okay, now let's move on to the next question. Now the next question states that the equation which links the current and the potential difference and power is equal to current times potential difference. We have to calculate the power output of the battery in the figure above. Now the one thing that you're going to do is that we have to know what the current is. Now we know the current in this case is I. Current stands for I, and the current is about 0.4 amps. Now where did I get this? I got it from the question above, that it stands for 0.4 amps. That's a current that's flowing there by the ammeter, which measures the current in one way. So since we know what the current is and we know what the PD is about 12 volts, so we're going to say that the voltage is about 12 volts. Now all you need to do is to substitute these two values into that equation and score those good 2 marks for the question. So you're going to have power, in this case is going to be P, it's going to be equivalent to 0.4 amps times volt times the potential difference is going to be 12 volts. So you have 0.4 amps times 12 volts. That's going to be about let's say 4.8. So 4.8 watts. Now the question clearly stated that we have to give this to about 1 significant figure. So 1 significant figure means it's going to become about 5 watts. So remember guys, you have to convert the power. So now it's going to be about 5 watts, and that's going to be about 2 marks there. It's pretty fun actually. Physics is pretty awesome, by the way guys. It's just more about equations and mathematics and a little bit of actually science concepts, but it's pretty easy guys. You guys can do it. So let's move on to the next question. Next question shows us the bar chart shows the power of 3 different electric hair dryers. Now, which one of the hair dryers, A, B, or C, would transfer the most energy in 5 minutes? So now for this one, you guys have to carefully understand that the bar chart is showing the power of these different electric hair dryers, and which one would transfer the most amount of energy would be A, since it has a about 1.5 power in kilowatts. So that's going to be A. So we're going to pick A since the others don't give much power in kilowatts. Now, next one, question 2. Question 2 states that a small travel hair dryer has a power of about 500 watts. Draw a fourth bar on the bar chart to show the power of the travel hair dryer. So now, since you have to notice something about this being watts, the bar chart has been shown in kilowatts. So we have to know that 1 kilowatt is about 1,000 watts. Now this is one hidden bonus tip that they're not going to give usually in the formula sheets. They're not going to give this conversion in iGCSE or GCSE. This is something that you guys have to know from the back end. So we know that it's 500 watts. So 500 watts to kilowatts, that's going to be about 500 watts divided by 1,000 watts to get you the value in terms of kilowatts. So this is going to be about 0.5 kilowatts. Now, since it's 0.5 kilowatts, now in order to draw this bar chart, what you're going to do is you have to draw the bar. It should be drawn with the correct height. So now, in this case, the width of the bar doesn't matter. So, but we're going to, since we know that they're leaving about 4 gap spaces, we're also going to do the same. So we're going to just zoom in, and we're going to use this point here, and we're going to count how many squares. So there's about 6 squares. I would prefer you guys just to draw about 6 squares, since all of this has a width of 6, but it doesn't matter. I think I just like putting it as 6 as the width. So in this case, we have to draw up to, let's say, to 0.5. So we know that 0.5 is somewhere roughly about here. So you're going to draw something like this, like a bar. It doesn't matter. If you guys would like, you can do a little bit of shading if you guys like, but it doesn't matter. Usually that doesn't matter, but you have to just show the points where it's clearly correlating with the bar chart. So yeah, it's kind of correct. So now that should give you about 1 mark. So shaded or not, they don't care. So just draw the bar chart, but shading it would be pretty advisable. Now let's move on to the next question. Now the next question states that a family shares the same hairdryer. Now the hairdryer has a power of 1.2 kilowatts. The hairdryer is used for a total of 2 hours each week. You have to calculate how many kilowatts of this energy the hairdryer transfers in 2 hours. Now show clearly how you have worked out your answer. So now this is the energy transfer. So we have to look at the clues that this question is giving us. The question is giving us the power is about 1.2 kilowatts. So you're going to write it down there. So you're going to write power, it's going to be P, is about 1.2 kilowatts. And we know that the hairdryer is used for a total of 2 hours each week. So in 1 week, you have a total time of about 2 hours. So that's what we're going to write down. Now we have to calculate how many kilowatts per hour, kilowatt per hour of energy the hairdryer transfers in 2 hours. So you're going to use a nice little formula, also known as, I like to use something called a formula triangle. You guys can search it up in Google or something, check what a formula triangle is. It's a nice simplified way of showing a formula. So you're going to write, you guys can use this formula EPT. So EPT just stands for energy transferred is equal to power times the time. So they've given you the power and they've given you the time, so you have to calculate how much energy is transferred. Now this is something that you will get in the formula sheet, so you guys can learn it if you guys want to, but it's usually given in the exam sheet. So you have 1.2 kilowatt hours times 2 hours. Now the reason I'm not changing any of these values is because the answer value is given in kilowatt hours. So that's something that you're not going to change. So you have energy is going to be equal to 1.2 times 2 hours. So this is going to give you about 2.4 kilowatt hour. 2.4 kilowatt hours. That's going to be your answer for about 2 marks. Let's move on to the next question. Now the next question states that the electricity costs about 15 pence per kilowatt hour. So what we're going to write is it's going to be costing 15 pence per kilowatt hour. So that's for 1 kilowatt hour. Calculate the cost of using the head dryer for about 2 hours. So since we know that it's about 2.4 kilowatt hours, all you're going to do is you're just going to multiply 2.4 kilowatt hours times 15 pence to get your cost in this case. So you have 2.4 times 15 pence, which in this case should be giving you a value of about 36 pence should be your answer. Alright, so 36 pence should be your answer. This is more likely a ratio type question, so you guys can do this. Let's move on. Total marks will be 6 marks. Let's move on to the next question. Now the next question shows us, I'm going to just zoom in a little bit so that you guys can see that, is that the appliances shown below transfer electric energy to other types of energy. This is a vacuum cleaner, there's a fan, iron, drill, washing machine, toaster, television. Now you have to understand something is that the vacuum cleaner is designed to transfer electric energy to kinetic energy. 3 more of the appliances are also designed to transfer electric energy to kinetic energy, which 3 you have to draw a ring around each correct appliance. So what this means is you have to find something that transfers electric energy, something that's found usually in the homes, to kinetic energy, to movement. So you have to understand that kinetic energy is something related to, let's just draw that arrow nicely, is something related to movement, alright? Movement. So what transfers power or electric energy to movement? So in this case, the answers could be, it's a fan, because fan creates movement. So you're going to say a fan. We're going to draw a ring around each of the correct appliances. So it's a fan that creates movement since motors rotate. A drill also creates movement since the blade rotates. I think it's something like that. Then you have a washing machine, something that turns around. So that's all these appliances have some form of kinetic energy of movement. So in the fan, the blade rotates. In a drill, the drill rotates itself. This portion here. In a washing machine, I think inside of the washing machine they rotate as well. So that's why we're circling only these 3 appliances which have something related to transferring electric energy to kinetic energy. Let's move on to the next questions. Now the next question states that which of the 2 of the following statements are true? You have to tick 2 boxes approximately. So appliances only transfer part of the energy usefully. I feel that is true because there is some form of wasted energy for all appliances. You have to remember that no machine is 100% efficient in terms of this case, except for an electric heater, because the heat is usually needed to transfer movement. But in conclusion, no machine is 100% efficient. So we have to move on to the next idea. So the next idea is that the energy transferred by appliances will be destroyed. That's not correct, actually. The energy transferred by the appliances makes the surroundings warmer. That is true because heat is a form of wasted energy. The heated energy would be transferred to the surroundings. So in this case, the energy transferred by the appliances will make the surroundings warmer. Now this is some good 2 marks for a total of about 5 marks for this per question. So pretty awesome, right? Let's move on to the next question. Now the next question states that you can see some 2 diagrams. So this is going to be a little bit more understanding involved. So a student used apparatus drawn below to investigate the heating effect of the electric heater. And we know that the graph A shows how the student expected the temperature of the metal block to change after the heater was switched on. You have to describe a pattern shown in graph A. Now if you see something about the graph, is that you can see an increase in temperature after the heater was switched on. Now we have to understand that what are these values of 0, 100, 200, and 300. Now these are values which we can understand is that we have to carefully look at the diagram. It shows a metal block, it shows a power supply. As you turn on the power supply, the increase in temperature of the metal block increases. Alright, so what you're going to say is that the temperature increase and the time are kind of directly proportional. Since this is 2 marks, you have to say as time increases, the temperature also increases as well. So that's something that you're going to write down as well, is that the temperature increases. Alright, Let's just write that down properly so that we can get it. Temperature increases. And then you can say that the temperature and time switched on is that the temperature and time switched on are directly proportional to each other. They are directly proportional to each other. So they're directly proportional. That's a key word to use here. They're directly proportional. So that's going to gain you some good 2 marks. Let's move on to the next question. Now the next question says that the student measured the room temperature and he switched on the heater and measured the temperature of the metal block every 50 seconds. The student calculated the increase in temperature of the metal block and plotted graph B. After 300 seconds, the graph B shows an increase in temperature of the metal block, which is lower than the increase in temperature expected from graph A. Now, suggest one reason why. Now, one reason why this usually happens is because some energy has been lost to the surroundings in forms of heat. So that's something we can mention for 1 mark. So we can say that the energy transfer from the block to the surroundings, this could be that, or the metal block cannot be insulated in one case. So, but I think the first reason is really good, is because the energy transfer from the block, is from the block to the surroundings is lost in the form of that heat. So we're going to mention that keywords there is being lost from the block. Energy has been transferred from the block to the surroundings. That explains the reason. Now let's do a little bit of calculation. Now the power of the electric heater is about 50 watts. So now this is something you have to mention. You have to know that the power is about 50 watts. And we have to calculate the energy transfer to the heater from the electricity supply in 300 seconds. So now the time is given in, let's say the time is given now for about 300 seconds. Now instead of kilowatt hours, now it's something called joules. So you're going to use the same formula EPT without changing the formula triangle EPT. So you have energy transfer is equal to the power. Let's just erase this portion. So the energy transfer is equal to the power times the time. So you have energy is equal to power in 50 watts times the time in 300 seconds. You have the energy is going to be, I'm just going to use the calculator, guys, for this. So you guys have to be quick in calculation. So you have 15,000 joules. Now this is going to be your answer for about 2 marks. So you have 15,000 joules. So now this is a nice way of using formulas in order to calculate these values. So the question itself gives you the values. All you need to do is just use the formula and calculate them accordingly. Let's move on to the next question. Next question states that the student uses the same heater to heat the blocks for different metals. Now each time the heater is switched on for about 300 seconds, each block of metal has the same mass but a different specific heat capacity. So now this moves on to a chapter of heat capacity. Alright, now you have to state up which one of these metals will heat up the most. So in this case, we know that aluminum has the highest specific heat capacity, and we can say that it takes time for it to heat up. And since lead has the lowest specific heat capacity, we can mention that lead is one of the metals that's going to heat up the most, right? Because it's going to be quickly heated up. Now the reason is because, now they're asking us to give the reasons in terms of the amount of energy, is because lead needs the least amount of energy. Lead needs the least amount of energy to raise temperature by 1 degree Celsius. Alright, so that's going to be a reason for about 2 marks. 1 mark is for circling the option, another mark is for stating the reason. That's why, because lead needs the least amount of energy to raise temperature by 1 degree Celsius. Alright, because the specific heat capacity of lead is the lowest among all the other metals. Let's move on to the next question. Next question shows us a lot of diagrams in physics, right? Okay, so question 5 is that the data included in the diagrams gives the power of the electric appliances. Now you have to understand which appliance is designed to transform electric energy to light and sound. Now, you have to understand is that everybody uses a TV, and we know that a TV is a substance that, not a substance, it's like it's an appliance that is where we watch physically and we hear sounds. So that seems to be the most reasonable choice. So it's going to be TV. Which two appliances transform energy at the same rate? So now this is more of a calculation question where you have to know that 1 kilowatt is equal to about 1,000 watts. 1,000 watts. So we're going to convert everything into watts. That's going to be the most easiest. So we know that 1.0 kilowatts equal to 1,000 watts. For the radiator heater, 1.1 kilowatts. For this one, you're going to have 1.1 times 1,000, which is going to give you about 1,100 watts. And we know that the sandwich toaster and the hairdryer have the same number of watts. So now when they ask you these type of questions, you're going to say the hairdryer, and the sandwich toaster. Sandwich toaster has about the same number of the transfer energy at the same rate because they have the same number of watts. They have the same number of watts of about 1,100 watts. So that's going to be our answer for 1 mark. Let's move on to the next question. Now the next question says that during 1 week the food processor used for about a total of 3 hours. Now we have to use the equation in the box to calculate the amount of energy transfer in kilowatt hours by the food processor in 3 hours. Now we have to show clearly how you worked out your answer. Now in order to calculate this is that we have to know the power, and the food processor, if we check, has about power of about 0.4 kilowatts. So we're going to say that the power, we're going to write down the power is equal to about 0.4 kilowatts, 0.4 kilowatts, and we know that the time took about 3 hours. That's something that you can mention there when dealing with this type of question. We have to calculate the energy transferred in terms of kilowatt hours, so we're not going to change any of the values. If it is not mentioned in kilowatt hours, you do have to change the values. So you have energy transfer is equal to 0.4 times 3 hours, which is going to give you a value of about let's say 1.2 kilowatt hours. You're going to write that down for about 2 marks. Alright, let's move on to the next question. Now the next question states the electricity costs about 15 pence per kilowatt hours. You have to use the equation in the box to calculate the cost of using the food processor for about 3 hours. Now they have given you a nice little equation, so now you're going to use the total cost to calculate. So we know that the number of kilowatt hours is about 1.2 times the cost per kilowatt hours. So what you have to understand is that we're using the food processor for about 3 hours. So we know that there's 15 pence per kilowatt hours. Right, so per 1 kilowatt hours. Since it's 1.2 kilowatt hours, we're going to multiply that by 15 pence to find out the cost of it. So it's 1.2 times 15 to give you about 18 pence, I think, approximately. So if you want to find out the total cost, it's going to be the number of kilowatt hours. So now in this case it's going to be 3 hours, but it's just going to be 18. Now the reason is because it's going to be 18 pence. So the total cost, if we check, is that the number of kilowatt hours is going to be 1.2 times the cost per kilowatt hours is going to be 15. Now this is a trick question. At first, after looking at this question, I thought we had to multiply this 3 hours or something, but that was just a trick for you guys to know that you have to just use the 15 pence, and you have to just use the number of kilowatt hours that you found from the previous question and multiply them together to give you 18 pence. That's going to be about 2 marks, total of 6 marks. Let's move on to the next question. Now the next question states, okay, that's a big question. Now this is more of a calculation for AQA electricity, huh? Okay, alright. So I'm not going to read this question, you guys can read it on your own, but I'm just going to go to the equation parts of this. So use the equation in the box to calculate the cost of the electricity used between 12 June and 13 September. So you have to show clearly how you worked out your answer. So we have to find out the number of kilowatt hours. We are given the number of kilowatt hours to be about to be about power of about 110 kilowatt hours. So what are we going to do? And we have to find out the cost per kilowatt hours. So the cost per kilowatt hours, if you can see clearly that it's about 15 pence per kilowatt hours. So you have 15 pence per 1 kilowatt hour. So that's going to be the same thing again, where you have the total cost to be about 110 kilowatt hours times 15 to give you a value of about, let's say, 1,650 pence. Now this, if you convert it, it's going to become about, let's say this is pounds, right? So pounds 16.5. So this is going to be pounds 16.5. That's going to be your total cost of about for the appliance for using the electricity between 12 June and 13 September. Now let's move on to the next question. Now the next question is that the estimated reading shown on the bill was not very accurate. The correct reading was about 53,782. Now how many kilowatt hours of electricity had the householder actually used between 12 June and 13 September? Now this is something that we have to understand, is that if the number of hours was that much, what we have to do is that we have to subtract this value from the original. So you're going to say that 53,782 minus this reading, that is 53,490, since we're changing the estimated reading, the correct reading. Now once you put this in your calculator, you should be getting a value of about 292. That's the amount of kilowatt hours that you're going to use in terms of doing this. So that's the kilowatt hours of electricity that the householder actually used between 12 June and 13 September. Alright, let's move on to the next question. Next question shows now another diagram. Seems to be like a repetition of questions here. So we're going to speed up. So now 4 of the appliances, including the fan heater, are designed to transform electric energy into heat. Name the other 3 appliances designed to transform electric energy into heat. We know that iron is also used to transform electric energy into heat, to heat up the clothes. To iron the clothes. We know that the hair dryer is also going to do that as well. We know that a kettle is also going to be used to heat the water. So now this is going to be your answers. Now let's move on to the next question. So now in 1 week, each kettle was used for about 30 minutes. Which kettle cost the most to use? So why cost the most to use that? Now the reason is because it has the highest power in watts. It has the highest power in watts. So that's the reason why we're going to choose Y. Seems to be 2Y. This should be Y here. I think this should be about Z, because there is an appliance of XYZ, right? You have to choose Y. Now let's move on to the next question. Now the new express boil kettle boils faster than any other kettle. Draw a fourth bar in the chart to show the possible power of an express boil kettle. Now since it boils faster, it should have a greater power in watts. So we're going to have an estimate of about, should be greater. This is just a rough guess, guys. So this should be the estimated bar graph. You guys can draw it properly, but it should be greater. It should have a bar drawn with a height greater than Y. Okay. All right. Let's move on to the next question. Now the graph shows the time of water, time it takes to boil water. So kettle depends on the volume of water. Okay. So now a householder always wants to fill the electric kettle to the top, even when only enough boiling water for 1 small cup of coffee is wanted. Explain how the householder is wasting money. So we have to look at the graph. Is that the bigger the volume of water, if you see the volume of water increasing from one point, you can see the amount of time it takes for the amount of that water to be boiled. So that's a lot of amount of electricity being used in that case. So what I'm going to say is that as volume increases, right? As volume increases, time increases to boil water. So more energy transferred. So more energy is transferred. alright, and costs more money since more electricity is being used. This costs more money since more electricity is being used, right? Since more electricity is being used, alright? So that's going to be your answer for about 3 marks. We're mentioning that the bigger the volume, it takes more time to boil, more energy is being transferred, and this indirectly costs more money. That's going to be about 3 marks. So let's move on to the next question. Now the next question states that energy cannot be transferred by convection. Now this is going to be happening through a solid. Convection usually involves gases and liquids, right? Now, next question states that you have to know that the temperature of the air inside the freezer compartment is about -5 degrees Celsius. You have to answer more than once or not at all. So now you have to use the correct answer from the box. So when the air near the freezer compartment is cool, the energy of the air particles is going to be decreased, alright? And the space between the air particles are also decreased again. Now, that's understood, and the density of the air increases, okay? The density of the air increases. Let's say it's going to be increased. That's going to be about 3 marks for that kind of answer. Now, the table shows some information about 3 fridges, A, B, C, and which fridge would cost the least to use for 1 year. So you can see that the volume in liters is increasing below as it goes from fridge A to fridge C, and the amount of electricity and the amount of energy used in 1 year also increases. So it's going to be fridge A is going to be costing the least to use for 1 year. Now the reason is because it has a low volume in liters, and it has the least amount of energy used in 1 year, unlike the other fridges. So you can say that fridge A uses least energy in 1 year. Least energy in 1 year. So that's going to be about 2 marks. Let's move on to the next question. Now, the householder looks at the data in the table above. What should she conclude about the pattern linking to the volume of the fridge and the energy it uses? Like I said, as the volume in liters increases, we're going to write that down as a volume in liters. As the volume in liters increases, the greater energy it uses. The greater energy the fridge uses. The fridge uses in 1 year. So now this is going to be our answer. As the volume in liters increases, the greater energy the fridge uses in 1 year. Alright, let's move on to the next question. Now the next question states that the householder cannot be certain that her conclusion is correct for all the fridges. So just one reason why. That's because there's a very small number of samples, right? Very small number of fridges sampled. We're gonna mention that fridges sampled. Right? That's gonna be an answer for 1 mark. You could also state that it's only tested 3, and and most appliances are in. There's insufficient evidence in data since it's only 3 number of fridges that are sampled, and a very small number of fridges are sampled. Let's move on to the next question. Next question states that an electrician is replacing an old electric shower with a new one. The electrician should not change the shower unless he switches off the mains electric supply. Now, the reason why he should switch off is the electrician, he could get an electric shock. He could get an electric shock if he touches the live wire. Okay, let's move on to the next question. Now, the new shower has a power output of about 10,690 watts, and it's connected to a 230 mains electric supply. Now, the equation links current, potential difference, and power. So we have to calculate the current. The current is about 10,690 watts, all divided by 230 volts. So your current is going to be about, I'm going to use a calculator in this case, alright? So it's going to be about, let's say, 46. You have to calculate this up to 2 significant figures. The question directly states that you have to calculate it to 2 significant figures. So you have 46.47, which is going to be about 46 amps. So that's going to be your answer. The current is going to be 46 amps. Alright, let's move on to the next question. Now, the new shower has the highest power rating than the old shower. How does the power of the new shower affect the cost of using the shower? You have to give a reason. So this means that the cost is higher, right? The cost increases. Cost is higher since more energy is used per second. Now this is something that you're going to write down for 2 marks. The cost is higher since more energy has been used per second. Now this seems to be the end of the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are on this video and whether I should continue solving past paper questions like these or continue solving topic by wise questions. And yeah, I think that's it, guys. This seems to be the end of the video. Do stay motivated and yeah, enjoy the video. Alright, bye guys.